Let's go. Good evening. I think it's number 14. Number 14. Normal probe 0 degree straight probe. That's the thing I will be talking about. Now, the calibration, the transfer correction, and then working. The same thing. That's from my writing. Normal probe calibration with version 1 block. The thickness of the block. Okay, now I understand that it's half of it is Lithuanian. Okay. You should see for correct spikes. Maybe the smallest number is 2. Okay. 25, 50, 75, 100. Okay, now velocity. You don't have a theory of ultrasound, so velocity of this beam. Okay. Okay, yeah. This beam, this probe, okay, and the straight probe, yeah. The sound goes differently at 90 degrees. Okay, it's 0 degrees, not 90 degrees. Differently than an angle probe. That's already evening. Because transverse waves, longitudinal waves, this is this sound goes by this speed, and this sound goes by this speed. Okay, why it's not 2 times? Well, just take the paper and and that's it. Okay, so for this one the velocity is different. I cannot explain that today. Velocity. Why? Okay, one of them goes like this, the sound. Okay, the other goes like this, and then is reflected and goes back like this. And this one goes in a different way. So these are 2 different waves, okay, sound waves in the metal. And that's it. That's the explanation for this thing that I am doing. So velocity is this one, and that one is for the angle probe. Single, double, okay. What should it, what's the, okay. 1, 2, 3, 4 parts. I should look at what you are looking at, not what I am looking at. First, check vertical linearity. That's what needs to be done. Okay, then check resolution, check sensitivity, and other. Okay, so here I have horizontal linearity, vertical linearity, sensitivity, and resolution. Vertical, horizontal. Okay, so this is the way resolution is checked. Okay, now this is the way sensitivity calibration. on the whole. This is resolution, this resolution is good. Now calibration for plexiglass, we don't need that. Amplitude control linearity for checking the gain first. Okay, I'll just do it and you'll see. Okay, but okay, so this is the plan. What you should check with the probe that you calibrate. Okay, so the plan is like this. I'll take this one with a double transducer probe, and do each of the steps with this one. Then I will see, because I just want to check. I have done that, but I have two single transducer probes. That's already not great. Okay, so another calibration I will do is, that's the straight also probe, and then that's it. So two probes, double and single, dual and single calibration, and then transfer correction for both of them, and then working with them. So I'll pause this. I think this will be double this video, the video 14. I will write that down now. So it's double. We need the number. So it is 5 megahertz. And the number ending is, okay, it can be 306R or 06R if we fit only 3 letters in. Okay, what else? Nothing. So here is the first part, that is probe number. That is 14. Now angle. Angle is 0. Okay, that was name. Angle is 0. Frequency is 5. That's the maximum according to our standard, that is 17640 maybe. 4. Calibration. X value. We don't have such a thing on the straight probe. Just move on. Real angle. We don't check real angle with a straight probe. It goes down, and it's something like down. It might be 1, 2 or whatever, but it goes down and back up. 6. Probe delay. We'll do that. We need to find that. Okay, so probe delay. Good. And then other things from the other paper, big paper. So for now, this is good enough for us to start. Now I will pause, but what I will do is switch on the machine, connect 2 cables, check that the transmitter is into T and receiver from there is into R, and then start. So what I have done is taken the V1 block. There is one V1 written on these ones. That is the real V1 block. And I have connected the probe, and I take now some oil and I put the probe on it, and then I take the tape and will glue it on. That's why I have taped it on because it doesn't fall and I don't have to hold it. Okay, so there is all underneath. And okay, here you can see that when I move it, it goes up, it goes down, but still I need the place for it, not the height of the spike. So it's standing in its place, and I don't need to move it now. So now what I'm going to do is put in double. Okay, what setting should I take from the some 70, let's say, probe? Let's take from the back and put it recall and use it to change. So I have like, let it be 60, whatever, yeah, recall. So now unfreeze. Now what I need to do is find the double. So it's in the pulsar receiver, dual off. I'm putting dual on because that's dual. Now 5 megahertz. I'm making it 5. Here you go. Done. The number later, I will put later in. 0 degrees. That is as I remember it in the big menu. Here you go. 1, 0. Enter. Home. Yeah, 0. 5 megahertz probe delay. Now thickness. We need thickness. 5. T is thickness. Sorry for the writing. Thickness is where I was. You shouldn't look at me now. You should look at this thing. Okay, thickness. The thickness of this block is 25. Let's try to change this thing and maybe play with this win, because the gate is some kind of big thing. Okay, enter, back, home. Frozen? No. Enter. What? Enter. Go home. Now I have switched off the legs. Okay. Going back. I color leg on. Color leg off. What's the problem? X value should know such a thing. So that should be 0. It doesn't have a X value. Yeah. Maybe I should pause. I was sitting there thinking why I can't see the legs, because color leg on, okay, on the other machine, still on the straight probe, I could see the lines of the legs. These are not legs. Legs are on the angle probe. But on here, when color leg on, you cannot see the legs, and color leg off, you cannot see. That was, I was just sitting and thinking, was the problem. But if I make it 1 degree, maybe I will see it. And 1 degree is good enough for me. Let's see. Yeah, okay. So I can work maybe with 1 degree, and then after the calibration I will switch back to 0 and check if the numbers are still the same or different, because 1 degree I have no problem with that. Okay, I want, because now I can see the thickness of the metal. Okay, just to experiment. I'll pause and experiments with another thing. Let's move on. Now, probe delay. I have no idea what it is, so I will just go up here and move it to the right. This one, I think when you push it, it becomes faster. Okay, now it's 0. You should make it 0. What else you can do is make this gate smaller, and yeah, because I don't like the form of it, and I don't like the color and the size of the green bar, but let it be this way. Threshold, I will put it like 75 maybe, because if I push 80, okay, plus 80, that outer 80 that is here, it should go through that. Here you go. Now, what we see now with all the zeros and the probe stuck here, okay, if I push it in a different differently, yeah, what you can see, it gets higher, so the connection is better, but I'll work with this thing now because I don't need to touch it. I will decrease the gain, or I can do the auto 80 here. When auto 80 of this one, when it's down there, the menu, okay? And now what we see here, well, that's wrong, and that's this should be the same thing, maybe. Yeah, we need the thickness in here of the first reflection from the bottom. It should be 25, then it should be 50, the third one should show 75, and then the fourth one should show 100. Okay, if the calibration is done correctly. Now, another thing that is wrong is velocity. So let's change the velocity to 5, 9, 20, but I will check maybe the documentation, or maybe not. 5920, 5900, so let's making 5920. Go to the velocity and push it to 5920, that is magnesium. Quartz. Still mild. Okay, I can use that. That's also on my paper, so either this one, but I will make it 5920 because I think that's in the standard plus minus something. So to the right, and we will make it custom. Here you go. Here is the 6-point velocity. Wow, that went away fast. Not good enough, not good at all. Okay, I'll fix that later. And now everything moved. So now the first one should be 25, but I haven't, it's okay. I will increase now the probe delay, so the first spike is 25, and I will find the probe delay. Okay. I will push it a little bit so it goes up. Now, no, decrease. Okay, 18. This should be on exactly on the line that I wanted to see here. I'll just tape it better. Now it's better. So I'm still decreasing maybe it a bit. Good enough, 2500. What I will do now is look at the data of my probes, and I want to go and find this number in there. Is it the same one that I did on the other machine or not? So I have done this 7380, and I will check now the historical data. And what I have here is from this probe I have 56 decibels. Well, that's high. 56, that goes through the roof. Okay. And then another thing is probe delay 723. 723, and I here have 7382. Okay, but I don't know the velocity that I used. Okay, so it's similar. If the velocity I change to like 900, then the probe delay changes a bit. So, but it's clear. Okay, it's near. So this one, but the plus the velocity is 5920. Okay, that's what I did. Now I have to check the other ones, and do they show what I want to see. So let's go and check other 4 spikes. 50.5, that's already a little bit off. Here 0.4 off. Here 0.3 off. So okay, I will change now the probe delay so that this thing becomes 100, and we'll return there and see what that first one will be. Okay, so now I go to the probe delay and change it, increase it or decrease it. Okay, let's make it closer to 100. Well, that will be off then. So it depends on what thickness you work, because either I want to be it precise near 25 millimeters or near 100 millimeters. Well, it depends on what you are checking. So I will make this one now 118. Now go back with the gate and check the other ones. Okay, let's check the other ones. Back here, it's smaller, 25. Okay, 31, and that is smaller. Okay, so that's already not, well, it changes. And okay, that's when I push it, it's a little bit different. Okay, yeah, the tape is off. Maybe it doesn't matter. Sorry. So, well, that is higher. Let's go check this one. That is smaller. That is higher. That is okay. Maybe it's good enough. We are talking about 0.5 millimeter and then 1/3 of the millimeter, and here it's like, well, 1/10 of the millimeter. Okay. These are good enough for me. Let's pause. Okay. Now, what I have done here is it's 100.16. I'm going back. Here is the end is 0.22. Going back. Here you go. It's 0.30. Going back. It's 0.41. Okay, now I will explain it in 1 minute, but that's too much, I think. So I'll draw down the thing. What this is, what we are looking is called horizontal linearity, and the calculation is like out of 6 spikes, you have it 150 here, and 3% can be the tolerance, and that 3% is 4.5 millimeters out of 150. Okay, if we are doing 4, then 3% is 3 millimeters. So you should check, do they fit into 3 millimeters? Okay, tolerance. Okay, so I have put like 0.16, 0.22, 0.3, 0.41, and yeah, that's good enough. The tolerance that I have in this paper is like 25.28, then I had 20, then I had 15, that I had like smaller one, 1. So at the end, these are like good enough, okay, because the millimeters are good here, so the tolerance is okay. So that's how you do the horizontal linearity check. It should show what you are looking at, okay? It should, if that's 25 and that's 50 and that's 100, it's okay, you can work with it, okay? That's all with the horizontal linearity without the formulas and stuff like that. Now what I want to do is, that was horizontal linearity. Vertical linearity or amplitude control linearity we'll do at the end. That's the thing how the machine works. Now the resolution check with this block. Okay, the second one is resolution check. To do the resolution check, you have to check 3 numbers: 91, 85 and 100. You put your V1 block like this. You will see maybe here, okay? Now you put your probe on it and you have to see 3 things: this reflection, and this reflection. That one is 91, that one is 85, and that one is 100. Okay, we need to check 3 things and to see them. That's the resolution. So I'll put the gel on, put the probe, and see what I can see on the screen. Okay. this one now. I am putting the probe here. I am trying to find, here you can see where it is. Now the thickness is wrong, as you can see. That's not 25, that's 100. Okay, so I'm going back to the big menu and I'm putting in the thickness of 100, the back wall there. Enter, back. Now I want to, no, the range is good enough. I want to increase the gain. The third one you can see here, okay? So when I move, okay, from the big one, okay, here you can see only one, the reflection from the bottom of the, like here, okay? Now I'm moving closer and I'm starting to see the second one and the third one reflection, okay? So here you can see that they are coming and they are going. Okay, so I want to put it so I can see, let's say 3. Here you go. These are different things, yes? 3 reflections. Now I need to hold it somehow so it gets good connection and I can move the gate and see the numbers. Okay, good enough. I move the gate to the first one. I should find something like 91 if I did a good job. Gate start. Well, that's 85. I don't like 85. Here is 91. Okay, so 80, yeah, okay, 85 is in the middle, yeah. Okay, I have this number 85 for sure, but I wanted, yeah. It's the highest one because it's the closest to the probe, okay? It's the highest, so the amplitude is, okay, here is 85, here is 91, and here is 100. So I'm checking now 85, yeah? And what's in the end? Nothing. So it's perfect, yeah? It's 0, 0. So it's what I have calibrated for. Here it's perfect. I can get 85 and 0, 0. Okay, now I want to take the second one, and if I can get it highest, I will check it with the same gate, or I need to make the gate smaller, bigger, whatever. Okay, so let's try. I saw something. Okay, here 91 and 20. Okay, now the second one is higher. Okay, so I got it 91, and that's the how you say it. I have no idea how to say it. I need to draw it. And then the last one is the 100, because the block is 100. So I'm moving it here. Here you can see, okay, I'm moving, so there are 3, but the highest one somehow should be 100, the last one. Okay, here we have 3, but I will move on this one. And okay, it's 100 and 0.26, fourth of the millimeter. Okay, so that's the resolution check. Okay, it's getting smaller. So the resolution check is to get 3 numbers that are close to these numbers. Okay, and if you are satisfied with the point something, you have done a good job. Now I have like here, okay, 100. So all these 3 are good for me. That's the resolution check. Okay, a little bit more. 3 spikes. The resolution check is 191 and 85, and what you get is something like that, all kinds of numbers. Okay, and if the tolerance is good enough after the point, then resolution is good. If you can see 3 things. Okay, pause and move on. The next part is sensitivity calibration with a 1.5 millimeter hole, and what you should find is 15 millimeters plus 35 millimeters. Here is the hole. The distance to it is 15, from here 35. You put the probe on here, check the hole, then you put it from the back and check the hole, and you check what numbers you get. Okay? What I have done is put some gel on here and on here, and what you need to do is move the gate to something like 1530. It's 100 here, so these will be here, and then maybe the distance, this one also decrease, so we're working with like 40 millimeters. Okay, I can do that. We go to range, up, decrease it to 40. Now I go to gate and make it here somewhere, like here, 30 here, and then 15 here. I can find this one and this one here. Okay, now what I do is try to find this hole, and that's 15. It should be 15. The hole is near the 15. Here I am moving it, coming up and down, coming up and down, appearing and disappearing, and I need to find it. Then maybe auto whatever, auto 80, up, and now I have 14. It's 15 and the hole is 1.5, so it should be something like that. Okay, can I get it higher? No, it's 14 and 20. Okay, so is this a good number? 14.4, 13.6, 13.5, 14.7. What I have is 14.30. Yeah, maybe it's good enough. From the other side, I'll put it, it should be like 35. Okay, so the gate is not where it should be. Let's move it a bit. Okay, 35. That's half a millimeter away what I have, so it's good enough from here. Yeah, you can see I'm moving down, nothing. Then this hole should appear, and then maybe it should disappear. Here you go, up, 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 up. That's not very comfortable, but it's in where it should be, 34 and 60, and here it should appear and disappear. Here you go, it appeared and disappeared, appeared and disappeared. Okay, so here is from the top. That's the sensitivity calibration and sensitivity check. Can you find this hole in the place you want it to be? Pause. Okay, so the last thing, I don't think it's simple entity, it's advanced. Amplitude control linearity, or maybe vertical also. So what I will be doing is I will take the first back wall echo, make it 80% screen height. You should do that if you do it very well, to make it many times, but I'll do it just once. Then when you decrease the gain by 6 decibels, the amplitude of this echo should decrease by half and become 40%. Okay, so with 6 decibels decrease, we should see the echo spike going from 80 to 40. Let's try. Okay, so I'm decreasing the gain. Okay, and then I'm going auto 80. I have done that. That's 80 now. Okay, the decibels is 41. I have to make it -6, so it will be 35. And what I would like to see, there is no grid, but this height should go somewhere to this height. Okay, so now I am decreasing the gain by 6, 1 by 1, 6 times. 1, 2, 3, 4, 5, 6. Okay, and that's not perfect because it's not maybe 40%, but maybe it is. I will move the gate to this 40 and check if this is 40 or not. So I will go to the gate threshold and move it now down and check if it's 40. And maybe it is. Well, that's perfect then, okay? Because I have decreased the gain by 6 and the spike went down to 40. Now I will increase it, the gain up 1, 2, 3, 4, 5, 6, and now I will increase the threshold to 80 and let's check if it's 80. Okay, perfect, that's working. So that's enough for this thing. Scientists do that like 5-6 times with all kinds of stuff, but that's the checking of this amplitude control linearity. It's the way the machine is working, not the probe. I have still 42 minutes now here in this video, so what I think I will do transfer correction with this probe. Here is my picture, and the problem is the same as I talked in the angle probe. Here we have reflections and we work with the first, second or whatever. Okay, now the surface can be different of the probe and working material. The metal also can be different of the probe or calibration block and working material. So to solve these two problems, we do transfer correction with this thing. We do the dark block on the calibration block, dark curve on the calibration block. Then we take this probe and we put it on the metal that we are working and checking the amplitude, how high the spikes are and what's the difference. Okay, that's the same thing but with this thing. So let's do that. But before that, we need to save this thing that we created. So I'm going now with this probe to here, files, and what I do is store data set, going up, taking some file, let's say this, no, this, no, no dark, this, enter, that's 0. I cannot delete it, so I will make it let's say 0 0, so I don't need to click it. That's 0 degree probe. The number is 306R, so let it be O 6 that's its number. That's the 5 megahertz, and that's it. And then I go and I save it. These settings of this probe are saved now. Okay, what I have done is put this probe, taped it. Now I have increased the range to 150. 1, 2, 3, 4, 5, 6 reflections I have. Okay, what I will be doing is now, with the same settings, I will go to duct ECG, and then what I will be doing is going up and recording points. Let's do this 80, auto 80 now. Here is the first point, auto 80 at 80%. Now what I will do is I will record the first point. Moving gate to the right. Recording. Moving gate to the right. Recording. Moving gate to the right. Recording. 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 That's my duct curve for the transfer correction. Now pause. I will make the same as with the angle. I will go now to offsets, stored, save this. Yeah, I have saved it now. Go down to the 4 offsets here, and I will make it to -12. -3, 6, 9, and 12. Okay? And pause this. This is the end result. I have -12, -9, -6, and -3. The duct curve with all the reflections. And okay, now if I push it, maybe it's not, the connection is not great all the time, but when I push it a bit, I can reach the top line here. Okay, that's the, let's say, the maximum that I can reach with this probe on this calibration block V1. Yeah, here, if I get the good connection. Okay, doesn't matter. Now I will just pause, take another piece of metal just to check where the lines are. I forgot to save it, so I am going now to the big menu, and then I'm going store dataset. Okay, now I'm going to change this to enter once again. That will be 0, that will be number. Okay, and then will be here, let's say, will be transfer correction duct. So it will be T transfer correction dark. Here's the name, enter, and then enter. Here, so that is transfer correction dark that I will use to do transfer correction checking. 50 minutes to go. So, okay, let's start with oil. Oil is bad on the surface that is sandblasted. Okay, so I put some oil on the 8, that is 30. And I put it here and I hold it. Okay, and what you can see is the maximum I can get. The spikes up is like to -9. Okay, that's what I can get. All these are going like 9, -12 under here. Yeah. Now you can see that the sound goes differently to, okay, here is a little bit higher, but then it doesn't reach there. Okay, the reflections and the metal do this. Okay, that's oil. Now try it on the same thing with the ultrasonic gel and more of it. I found that when you start working with it, it's worse. But if you do transfer correction when you finish scanning, okay, the result can be better. So, because it's somehow gets into the metal. Okay, so here with the gel on this surface, I can get a little bit higher. I think here I could get -6 maybe. Yeah, you can see that if I'm scanning the surface here, okay, yeah, maybe I can reach -6, -7. Okay, so it's not like -12. Okay, here I can reach something here -9, but it's a little bit higher than the oil. Let's do the same thing with the 30. Now with oil, what we will see is here. Yeah, it's -9. It's -6, not 6, but yeah. I can move the gate, but that's why I'm using these lines, because you can just see that it's like -8. Okay, yeah, -6 maybe I can reach. Okay, now let's put some gel and see, is there a difference? Okay, I have -6. I have it over a little bit, so okay, I have over 6, so -5, 4 already. Okay, a little bit higher, so the gel on this surface works a little bit better. I will take the other metal now, the 12, because with the angle probe it was higher. I want to check if this will shoot through the roof also, so wait a minute. I remember with this one it was like not minus, but I think plus transfer correction. So let's use the gel now on it and let's check what we have. And what we have is no big deal. Okay, it's like -3. Here you go. Yeah, I can reach -3. And the first reflection is smaller, you can see, than the second one. Yeah, over -3 I can reach here. Now let's use some, okay, a little bit higher. Let's use some oil on it. I need to clean the probe. Okay. Because the result will be messed up. Okay. Nothing special. Yeah, it's similar. But the gel I think was better. Here is under 3. Okay, so I cannot reach over it. So yeah, gel is better in these things. Okay, that's transfer correction. Just pause and then speak. I think I won't do all of this the second time with this thing because it's the same thing. And you will find all the steps the same. Maybe the resolution is better or worse to check this with the block where the 3 things you should find, but you can find it also with this thing. So I don't think it would be useful to repeat everything that I have done here, because it's not like with the angles, different things, different measurements, different. No, that's the same thing. It goes straight down and it has only one part, so no use, I think. So I won't do that. The next part I think will be tomorrow, is how you work with it. And how you work with it, I have still 3 minutes left. Maybe I'll show you in 1 minute how you work with it, and then I don't need to make a 1-hour video about it, okay? What you do is you put some couplant gel on the weld, and you put in the thickness of the metal into the machine. I will do that with this thing, the transfer correction thing, okay? So what I have done is put the thickness, and I can still see the legs because it's 1 degree probe, okay? Then what it means that here when I put it on, I can see first reflection from the bottom, second, third, fourth, okay? And then what I do is I scan near the weld, okay? And I want to find something in here or in here, because if there is nothing here in this metal, okay, I won't find anything. But if there is something, I will find it here. So you just go like this and you check if there is something between in the green or the gray area, okay? And if there is nothing, then this metal is clean. Then you go on the other side and you check, and okay, like this. I have still 1 minute left. Okay, and you can see that there is nothing in the yellow part, only the reflection on the back. Okay, 1 minute left. I'll show you what you don't want to find. Here is the metal and here is the holes. I will go through here and you will see where you can find something. I don't know why I am such in a hurry and I want to do it 1 minute, but I can do 1 hour, 5 minutes. Okay, so what I have done is I have put some gel on it. I have changed the thickness to 10 millimeters. Okay, I am increasing the velocity, okay, the gain, because my transfer correction shows that this is -6. What I can get out of it is not there, but -6. So what I want to do, okay, is just increase so it's higher. Okay, let's now I need to do it in transfer correction. And I don't want to do that today. Okay, let's do that. I'm going to duct ECG. What I need? -6. Okay. I am going to duct ECG up. Now I am going to offsets. I'm going up and I'm building it +6 here, so it reaches where I want it to reach, here. Great. Go back. Now. Okay. When I'm scanning the clean metal, look at what it shows. You can see the back wall, the back wall, the back wall, many reflections here, but here is clean. Okay, here you can see that there is nothing on the yellow and there is nothing on the green. Yeah, a little bit, but that's not the defects. Now I'm scanning in the middle where the holes are. And here is what you don't want. You should find it because it's your job. Okay, so here I'm starting and then I'm moving left, and here you can find something that should not be there. Okay, here I'm turning around and okay, this way maybe. Okay, here appears, disappears, appears, disappears. That's the hole at the bottom. Okay, now I'm moving. Okay. I can check what's the depth and things, okay, but that should not be there. Okay, moving on. Here, that should not be here. Okay, this thing, that should be clean. I should see the back wall only. I'm scanning. Okay, here another thing. Here, because the depth of these holes are different. Here, it's here. That's a defect. You don't want to see it here. And here also something appears, something disappears. Okay, so here are all kinds of things that should not be here. Okay, these things. Now here is where there is nothing, and here on the side there is nothing, and here, and you can see that when it reflects from this one gets smaller, this one gets bigger. Okay, here, this one, the back wall. Now you cannot see the back wall because you can see this thing. So when you're scanning through the surface of the weld, what you want to see is clean, all the thickness clean, and the back wall here. Okay, you can do this way. You just decrease the range to the first back wall reflection here. Okay, that's the back wall. Okay, and then when you scan, these are the things that you don't, okay, your client doesn't want to see. Yeah, these things that appear, this thing, and disappears. Okay, then this thing, okay, then this thing, yeah, and this thing. So this is what you, if you find something like that, then you should do more work on finding out what is there and how to identify it and things. That's not for this video. Okay, you just scan through the near the weld, the heat affected zone, the rust zone, and then most often you won't find anything. But if you find something, then you have a problem in there. Okay. Okay, I have done also the usage. I will think about it if I should do more videos about the usage and things like that with this thing. Maybe I'll do that later. For now, that's the straight probe with everything in one video. If you have some questions now, you should leave them under the video and also under the other videos. Yeah, and maybe out of these questions, some when I get to the first one, okay, or 1000 questions, then I'll make some more videos with this machine on another machine. So that's it for now. Good luck, and yeah, good luck for Rokas that will look at this thing when he gets to work with this machine some 5 years later, and will be happy to find something like that on the internet. Good luck, guys and girls. I know one that is working in NDT, so they are there somewhere. Good luck.